Chillers, cooling towers, and air handling units work together in a central air conditioning system to cool and circulate air throughout a building. The chiller is responsible for cooling the water that circulates through the cooling tower and air handling unit, which in turn, cools and circulates air throughout the building. The air handling unit, AHU, is a device that conditions and circulates air throughout a building. It is typically installed in the building's mechanical room and is connected to the ductwork that distributes air throughout the building. The AHU contains a blower fan that pulls in air from the building's interior spaces and passes it through a series of filters and cooling or heating coils before distributing it back into the building. The working principle of an AHU involves several stages. Firstly, the air enters the AHU through a duct and passes through filters to remove dust and other contaminants. Then, the air passes through a cooling or heating coil, which either removes or adds heat to the air depending on the desired temperature. Finally, the conditioned air is distributed back into the building through a series of ducts and vents. Air-cooled chillers use air as the refrigerant to cool water. These chillers contain a compressor, an evaporator, a condenser, and an expansion valve. The compressor compresses the refrigerant gas, which then flows through the evaporator, where it absorbs heat from the water. The refrigerant then flows to the condenser, where it releases the absorbed heat to the surrounding air. The expansion valve reduces the pressure of the refrigerant and sends it back to the evaporator to start the cycle again. An example of how these components work together would be in a large commercial building. The chiller would cool the water that circulates through the cooling tower, which would then distribute the cooled water to the AHU. The AHU would condition and distribute the cooled air back into the building. The cooling tower would release the heat absorbed from the water back into the environment, completing the cycle. This system allows for efficient cooling and circulation of air throughout a building. An example of an air-cooled chiller is the Trane air-cooled chiller, which is used in a variety of commercial and industrial applications. The Trane air-cooled chiller uses environmentally friendly refrigerant, which is an important consideration for modern HVAC systems. The chiller is designed to provide reliable, energy-efficient cooling for large buildings and facilities. The chiller is equipped with variable speed compressors and fans, which adjust the cooling capacity to match the cooling load, resulting in energy savings. The chiller is also equipped with an electronic expansion valve, which provides precise control over the refrigerant flow and improves the efficiency of the system. In addition to the chiller, the Trane air-cooled chiller system includes an air handling unit, which conditions and circulates the air throughout the building. The air handling unit contains a blower fan, a cooling coil, and a heating coil, which work together to maintain a comfortable temperature and humidity level within the building. The cooling tower is another important component of the HVAC system, as it removes the heat absorbed by the cooling water in the chiller. The cooling tower works by using a fan to draw in air, which then passes over the water in the tower and removes the heat through evaporation. The cooled water is then sent back to the chiller to start the cycle again. In summary, the chiller, cooling tower, and air handling unit work together in a central air conditioning system to cool and circulate air throughout a building. The chiller cools the water that circulates through the cooling tower and air handling unit, while the air handling unit conditions and circulates the air throughout the building. The cooling tower removes the heat absorbed by the cooling water in the chiller, completing the cycle.